So, let's see our work in here and determine the polar coordinates, all right, of this r cis theta given raised to a certain power. So let's read the instruction first and see how we can work on this one, okay? Jalen, go ahead, please. The one on top.
So the following exercise will find the power of each complex number in polar form.
Right. So powers of each complex number in polar form. Again, the polar form is in r cis theta, where r is the radius, modulus, or absolute value, and theta is the angle. Technical term for such is argument. Okay. So choose a number. Kylene, 35, 36, or 37? 37. So we got what? Find z squared when z equals 3 cis 120 degrees. As you may notice in here, the angle is in degree form. It can be in radian form as well. Depends on the given. So in here, 3 cis 120. Now, how do we get z squared? So according to our formula, whatever your modulus is, your r, you square it. Okay, whatever power it is, you raise it to that power, that modulus. And then cis, now whatever your angle is, 120, you multiply it to the power instead, right? So you don't raise the argument, you simply multiply the argument with that exponent, okay? So with that being said, how much is this gonna be? What's 3 squared? 9. Cis, and what is this? 240 degrees, okay? So that will be our z squared. So as simple as that one. Whatever your r or modulus is, you raise it to that power n, in this case 2. Whatever your argument is, your theta, whether that be in degrees or radians, you multiply it, not raise it to a power, right? You multiply it to whatever your exponent is. Questions? Questions? In some cases, you would convert this one into a rectangular form as well if needed. In this case, it's not needed, but if in case you need it to be converted into a rectangular form of a plus ba form, what will this be? That'll be 9 cosine 240 plus I 9 sine 240, right? And that will be the a plus bi form instead, right? What's cosine 240, by the way? Cosine 240, what's that gonna be, guys? What quadrant? 3, right? And cosine 240 on your unit circle will be what? Negative 1/2. Correct? Okay, times 9. Plus, this one is 9i. And what is sine 240? Quadrant 3 is still negative.
Negative square root of 3 over 2.
Very good. That's it. Okay. So, again, this is not needed. But again, in case it's needed, then you write it in that form, right? Question, that will be our z squared in what you call a plus bi form. Again, only if needed. Questions? Next one, and the last one in here is the reverse of raising it to a power. What if you get the what? The nth root of a certain complex number in its polar form, r cis theta, right? So the formula is as follows. The nth root of z, your complex number, is equal to what? Nth root of its modulus, cis, your angle, given angle, plus in radians, you multiply it with what? 2k pi, or multiples of 2 pi, or multiples of 360 in degrees, over what? N. Okay, over N. So, let us consider one particular example for that. Number 41, 42, or 43. let's read the instruction and see how we can work on, let's say, number 43 in this case, okay? Krish, let's read number 43. Evaluate.
Evaluate the cube root of z when z equals 32 cis 2 pi
5 over 8. Thank you, okay? So that's it. What's the given again? Z is equal to 32 cis. In this case, we are now given radians. Okay. Again, it can be in degrees as well. We need to get the cube root. So here it is, the cube root of z, that means n is equal to 3, is equal to what? The 32, you're gonna get the cube root of 32 as well. Okay, and then what? Cis, you see this 2 pi over 3, I'm gonna copy it like such, plus what? 2 k pi over 3. Once again, your n is equal to 3 because it says what? Cube root. Okay. That's the index. Now, what will be your k? So what is our k in here? Your k will be starting with the following. 0, 1, up to n minus 1. Since your n is 3, what's 3 minus 1? 2, right? So 0, 1, and 2. So we're looking for what? 3 values for the cube roots. Okay, so what are those? The first one is for k equals 0. So you see this one, we're going to evaluate this as following, right? K equals 0, this will be what? Square root of 32, which we cannot simplify anymore, okay? Because 32 is 2 to the 5th power anyway, okay? Cis, what's this? 2 pi over, what's 3 over 3? 9. Okay, once again in here, if k equals 0, this is gone, and 2/3 pi divided by 3 is 2/9 of a pi. Questions, guys, with that? Why this becomes 2/9? 2/3 divided by 3 is 2/9. Okay, so let me just complete it in here, right? So that's 2 pi. Okay, let me copy it here. 2 pi over 3 plus, what's this? 2 times 0 times pi, right? Okay, all over 3, right? So honestly, this one is gonna cancel out. Okay, and then 2/3 of thirds is like 2/9. That's it. Cube root of 32, cis 2 pi over 9. That's just the first root, okay? First cube root. And how many cube roots are we looking for? 3 cube roots, okay? What's the second cube root? K is equal to 1, so just the same. Cube root of 32, cis, this one now is what? 2 pi over 3 plus 2 pi, right? Your K is 1 over 3. Okay. Honestly, that one in here, you can just plug it in your calculator to get the value. Okay. So, in my calculator, I'm just gonna put in the fractions without the pi. What's that again? 2/3. Okay. Plus 2 divided everything by 3. Get it? Okay. So once again, that's 2 pi over 3 without the pi, that's you, plus 2 pi, again without the pi, all over 3. Okay, that's your n. Click on this to get the fraction. That's what? 8/9 of a pi. Okay, so in here, that's the second root. Cube root of 32, cis, what's this again? 8/9 of a pi. That's the second cube root. And lastly, we're going to work on the third and the last cube root, right? So what's the third and the last cube root? That is when k is equal to 2. So let's do it in here. K is equal to 2, just the same. Cube root of 32, cis, once again in here, 2 pi over 3, oops, plus, What's this? 2 times 2 times pi, which is what? 4 pi, right? Okay. All over 3. Okay, so do the same in here. Just copy this, square root of 32. Sis, now in here, Mr. Deal, how do we deal with those? Again, use your calculator, okay? So we have a calculator anyway. Just remove the pi first and plug it in here, okay? What's that again? 2/3, okay? Plus 4 pi, okay? Again, I'm putting everything in here without the pi because these are what we call complex fractions. We don't want to deal with fractions at too much. But you have your calculator, make use of that, okay? Over what? 3. That's the root, okay? Click in here. This is the last root, the biggest root, biggest cube root. And what's that? 14 nines. Okay, so put it in here, 14 nines. So that's the smallest cube root, middle cube root, and the biggest cube root of 32, sis 2 pi over 3. Okay, so whatever your roots are, you count how many are in there. So for cube roots, you are looking for 3. For square root, how many values are you looking for? 2. Very good. Excuse me. For fourth root, how many are you looking for? 4. Okay, so it depends on that. And basically, you just change this k into what? 0, 1, 2, until 1 less than whatever the root is. Okay? At 0, that's the smallest. At n minus 1, that's the biggest nth root for such a value of polar complex. Questions? Questions, guys? That's it. That ends our, thank you, Chase.